I wanted to make a video to help you with partitioning line segments. So partition a line segment. In this case, on Delta Math, it's referring to something called a directed line segment, which simply means that it has a one coordinate that is considered the beginning and the other that is considered the end. So partitioning into a ratio of 1 to 5. So that means we need a total of 6 segments. If we need 6 segments, then we need 7 points. Three segments, 4 points, 4 segments, 5 points, 5 segments, 6 points, 6 segments, 7 points. All right. So this will just look a little bit different from what we did in class, but not much. So this is my x, comma, y. And I want to partition it so that I end up with 1 segment to 5 segments. 1, 2, 3, 4, 5. So that means that I would want my partition to be right here. So I'm looking for this point. Now I'll fill in my start, x equal -10, and my finish, x equal 8. So then to get from -10 to 8, I'm going to add 18. And just to confirm with you how we figure that out, we have x2 minus x1. So you have 8 minus -10 is 8 plus +10. Is 18. And then we have a total of 6 segments, or 6 moves. 1, 2, 3, 4, 5, 6 moves. So that means that this should be divided by 6. So we're actually going to add 3 per move. And this is the change in x per segment. Now over here on the y side, we are starting with y equal -3, and we're finishing with y equal +9. So to get from -3 to +9, we need to add 12. And we can find that adding 12 by doing y2 minus y1. So we have 9 minus -3 equals 12. And then we have 6 segments. So we have 12 over 6 equals adding 2 per move. So I'm going to do all of the coordinates, but in this problem, you'll see that you would not have to actually do all of the coordinates because you already realized that this point is the one that will divide you so that you have 1 to 5. But I'm going to put the other coordinates in anyway so that you can keep watching and see how we know that we're correct. So I'm at my x of -10, and now I'm going to add 3. So -10 plus 3 is -7, then plus 3 is -4, -1, 2, 5. And the reason I did this was so you can see how to check your work. 5 plus 3 is 8. So then that should give you confidence you did it correctly. Now we'll look at the y values. We're starting at y equal -3, and then we're going to add 2 in every move. So -3 plus 2 is -1. -1 plus 2 is 1. Plus 2 is 3. 5, 7, and then plus 2 more is 9. But again, we already figured out that this is the coordinate that we want to partition to break this longer line segment into 2 smaller line segments in a ratio of 1 to 5. So that means our coordinate for our answer is -7, -1. Be careful when you put this in. Make sure you have parentheses. -7, -1. And that's how you do that. There's one other thing that I wanted to show you. This is a different kind of problem. This is breaking a line segment into ratios. All right. So points A, B, C, and D all lie on the same line segment in that order. So we have a line segment. A, B, C, D in that order. Now you should be aware that this is not to scale. And then it tells us that our total length from A to D is 18. And then the ratio of each line segment is 1 to 4 to 1. So if I add each of these up, like I did in the other kind of problem, they add to a total of 6. So hopefully this is giving you a clue of how you're going to answer the question, how long is CD? How long is it from here to here? If the total is actually 18, and then the ratio is 1 to 4 to 1. So what will happen is all of our fractions here are going to be equivalent with 6 over 18. So that means they're equivalent with 1/3. We could say 1 times 6 is 6. Something times 6 is 18. That something is 3. And that tells me that the actual length from C to D is 3 units. If you wanted to know the other ones, then here you would have 12. Because 4/12 is equivalent to 1/3 is equivalent to 6/18. And then this would also be 3 like the other one is. But my answer here is CD is 3 units. And those are the two new kinds of problems in this assignment.